Algebra 1, Sensei Learning System, Lesson 18. We'll be solving quadratic equations by factoring. Start off with this quadratic right here. We're going to factor this into two binomials, set equal to 0. Okay, so 3x squared can factor into 3x times x. The 2 can factor either into 1 times 2 or 2 times 1. Let's try 1 times 2. 1 times 2. Here this will give us 1x, and here this will give us 6x when we multiply. Now the question is, can the signs be the same and give us a 7x? And the answer is true. If these are both plus, then we do get 7x. Okay, since we now have plus and plus, we can now take both of these factors here and set them individually equal to 0. So this is 3x plus 1 set equal to 0, and this is x plus 2 set equal to 0. Subtract 1 from both sides here, and this becomes 3x equals negative 1. Divide both sides by 3, and we end up with x equals negative 1/3 as a solution. Here we'll subtract 2 from both sides. We end up with x equals negative 2 as our second solution. So 2 solutions for that one quadratic. Let's go back here. Okay, 6x squared minus 13x minus 5 equals 0. We'll factor this into two binomials, set equals 0. And 6x squared, we'll factor that into 3x times 2x. And the 5, we can either make that 1 times 5 or 5 times 1. Let's try 1 times 5. Inside, this will give us 2x. Outside, this will give us 15x. So the question is, can we have this different signs, right here, different signs, and get a negative 13x? And I believe we can. We can have positive here and a negative here, and that will combine and give us negative 13x. So positive and negative. Now let's take both factors, 3x plus 1, set it equal to 0, and 2x minus 5, set that equal to 0. And we'll solve for x. I'll subtract 1 from both sides, and this will give me 3x equals negative 1. Then I'll divide both sides by 3, and this will give me a solution of x equals negative 1/3. Here I'll add 5 to both sides, and this will give me 2x equals positive 5. Then I'll divide both sides by 2. I'll end up with x equals 5/2, and these are my two solutions. Next, I have 5x squared minus 13 plus 6. We're going to factor this into two binomials, and we'll make factor 5x squared into 5x times x. Now 6, we have plenty of choices. 1 times 6, 2 times 3, 3 times 2, and 6 times 1. Many choices on that one. Let me begin with a maybe a 2 times 3. That might work. 2 times 3. So 2 times 3. That'll give us 2x here, and that'll give us a 15x outside. And we want the same signs and to give us negative 13x. Well, we can't have same signs here because same signs add, and we'll get 17. So let me try another combination. Let me try the combination of 5x times x, and instead of 2 times 3, let's try 3 times 2. This will give me 3x on the inside, and outside we'll get 10x. Now, can I have same signs and get a negative 13x? And the answer is true. If both of these are negative, we'll get negative 13x, and those are same signs. So both of these will be negative. So I'll set both factors equal to 0 and solve for x. So we'll have negative 5x minus 3 equals 0. Add 3 to both sides, and we get 5x equals 3. And divide by 5, we end up getting x equals 3/5. Here, I want to add 2 to both sides, and my solution becomes x equals 2. For number 4, I'm going to factor this into two binomials, set equal to 0, and 3x squared, let's make that 3x times x, that makes 3x squared. And for the 2, we'll make that, we have a choice of 2 times 1, or 1 times 2 and 2 times 1. Let's try the 1 times 2, see if that works. I get 1x on the inside, and I got 6x on the outside. So the question is, can we have different signs and get a negative 1x? And the answer is no. We can't have different signs here because we'll have to subtract, and we would not be able to get the negative 1x. So let's try 3x times x, but 2 times 1 instead. This will give me 2x and a 3x. 2x on the inside, 3x on the outside. And I can have different signs, and I can get a negative 1x by having a positive here and a negative there. That combination gives me a negative 1x. So let's use positive and then negative. So I'll set my first factor, 3x plus 2, equal to 0. And my other factor, x minus 1, equal to 0. Subtracting 2 from both sides, I end up with 3x equals negative 2. Dividing by 3, we get x equals negative 2/3. For this one right here, I'll add 1 to both sides, and I'll get x equals 1 for my second solution. Okay, let's take a look at these. Okay, if I factor this into two binomials and set it equal to 0, x squared is x times x. For 5, I have a choice of 1 times 5 and 5 times 1. Let's start off with 1 times 5. That gives me 1x, and outside gives me 5x. I want to use same signs and to get 4x. And I can't use same signs here and get a 4x. So this right here is prime. It cannot be factored. So cannot be factored. Okay. The next one, we have x squared plus 1x minus 12 equals 0. Let's factor that into two binomials, set equal to 0. X times x for x squared. And for 12, we have many choices. We have 1 times 12, we have 2 times 6, we have 3 times 4, and the list keeps going on. I'm going to start off with 3 times 4. 3 times 4 gives me 3x, and gives me 4x on the outside. I need different signs, and I need to end up with a positive 1x. I can use different signs of negative and positive here, and this will give me positive 1x, that combination. So it'll be a negative first and then positive next. So I have x minus 3 equals 0 and x plus 4 equals 0. If I add 3 to both sides here, I'll get x equals 3. If I subtract 4 from both sides here, I will get x equals negative 4. Okay, here I have a difference of two squares. I'm going to take the square root of x squared and get x, and the square root of 1 and get 1. This will now give me conjugates of x plus 1 and x minus 1, and all equal 0. Now let's take each individual factor, x plus 1, set it equal 0, and x minus 1, set that equal 0. And I subtract 1 from both sides here, and I get x equals negative 1. Here I will add 1 to both sides. I know it doesn't like a 1. X will equal 1, and those are my two solutions, negative 1 and 1. Okay, for this problem here, I'm going to take the square root of 9x squared. This will give me 3x. And then the square root of 16, that'll give me 4. And my conjugates will be 3x plus 4 and 3x minus 4. And all that's set equal to 0. And then I take each individual factor and I set it equal to 0. Okay, subtracting 4 from both sides here, I'll get 3x equals to negative 4. Dividing both sides by 3, because I'm out of room, I get x equals negative 4/3. Here I'll add 4 to both sides, giving me 3x equals positive 4. If I divide both sides by 3, I'll end up with x equals 4/3, my second answer. Okay. These are conjugates right here, so I'm going to take the square root of them. The square root of 4x squared is 2x. The square root of 25 is 5. So this will be 2x plus 5 and 2x minus 5. When I solve, I'll get 2x plus 5 set equal to 0 and 2x minus 5 also set equal to 0. Subtracting 5 from both sides, I end up with 2x equals negative 5. My final solution will be x equals negative 5 halves. For this one, I will add 5 to both sides. I'll end up with 2x equals 5. And if I divide both sides by 2, I'll get x equals 5, positive 5 halves. Okay. And for this one right here, I'll factor this into the square root of 49 is 7, and x squared is x, and put 7x on both sides. The square root of 121 is going to be 11, so it's plus 11 minus 11. So I'll set both factors equal to 0, and then solve for x. So I subtract 11 from both sides here. I get 7x equals negative 11. This implies that x is going to be negative 11 over 7. For this one, I'll add 11 to both sides. This will give me 7x equals 11, and that implies that x equals positive 11 over 7 for my solution.